Okay, cool. I just noticed I was muted. So let's kick it off. I think we have a good people already on the call. Yeah, we're 5 minutes in, already a little bit late. So thank you all for joining. Thank you, Figment, for hosting this workshop, really. As you guys know, Figment is one of the core devs that's been working on the Graph protocol. They've been doing a great job in decorating Graph node with Tendermint-based chains. As you know, we've recently announced support for Cosmos. Osmosis and Juno are also coming to the hosted service very, very soon. And so we're today taking the time to go through to learn from Figment what it means to build subgraphs for these chains, particularly focusing on the data models, what it means to build subgraphs for these chains, what are app chains really, get to know a little bit better the Cosmos ecosystem. And I think we can be fairly interactive, meaning we have subgraph developers, subgraph guardians joining the call, and they should be able to ask questions so they can then know how to best address the community and provide the proper tech support. So feel free to reach out and ask questions. I'll be monitoring the voice chat channel as well as Spain. And yeah, Figment, Jared, Bartosz, let me know if you guys are ready. I think you can get started. So I think you should already have the presenter role. So let me know if everything's working well. And I'll leave the floor to you guys.
All right. So hi, everyone. So I'm Bartosz. I work at Figment, and we are really excited to show you something we've been working on for quite a while right now, which is the Cosmos integration. So our plan for this meeting is actually to start with some brief introduction. Like I'll just describe what we did in really brief way, and then we can go to this Q&A session where we hope to answer all your questions, like maybe ideas, some ways to improve what we did. But yeah, that's the plan for this meeting. So I think we can start. So what we did is we integrated Cosmos, but we did it in a way that actually allow us to really use the power of the whole ecosystem, let's say, because we have a couple of ways in which we could do this. One way was to actually create a separate integration for each Cosmos chain that there is in the Cosmos ecosystem, but we actually took a different way. So our way was to integrate on the Tendermint level, and the Tendermint is a library that is used for all of the different Cosmos chains in the Cosmos ecosystem as a consensus mechanism. So by doing that, we actually we are now able to integrate all of those different Cosmos chains very fast, because we built the foundation, which is we integrated the graph with the, let's say, with this Tendermint library. And by doing that, we actually can now integrate all of those different chains basically by just instrumenting the nodes. So what we used for this integration is Firehose, which is a framework created by a company called StringFast. And that also helped to speed up the whole integration, because what we really needed to do was to provide a data model for all of those different chains, and just all of the features of Firehose that are used in the graph node can actually be used for all of our Cosmos integrations. As far as the data model goes, we the good thing about the chains in the Cosmos ecosystem is that both the Tendermint library and the Cosmos SDK both provides the data model in the form of protobuf messages. So everything, all the data structures, both in Tendermint and Cosmos SDK, are defined by protobuf files, which are already there. So we just integrated that. We didn't have to come up with our own, create our own data model for this integration. We basically used whatever were in the Tendermint library and Cosmos SDK, plus some we added some additional fields just for to basically make the developer experience, Subgraph developer experience better. We added some additional fields there, but mostly it's just whatever it is in the Tendermint and Cosmos SDK library, which makes it, I think, easier for people coming from the Cosmos community. If they already know the data model, it would be much easier for them to just use it on the graph because they are the same data structures. So yeah, that's the data model part. I can, if you like, I can show it to you later on. But I think we can start with just me showing you how to, like, just a really simple subgraph example that we created specifically for CosmosHub, but it actually works for all the different Cosmos chains. So let me share my screen. Can you see it?
Yep, we can.
All right, perfect. So here's one of our examples that we provided for this integration. It's called validator rewards. So as you see, like the subgraph manifest, it's pretty much the same as the one for Ethereum. There are kind of like three changes, three differences that are here. First one is there's a different kind here. So for all of those Cosmos chains that we integrate, the kind here would be Cosmos instead of Ethereum. So that's the first difference. That's very important. Here's this like the protocol name. So that would be like an Osmosis chain. It would be Osmosis 1, I think. So basically, this is the way to specify which chain we're interested in. And the second change is the different, like the handler types. So we actually, like in this integration, we have three different handlers. One is a block handler. There's a similar one in the Ethereum integration, like this basic, those normal, like this original subgraphs, let's say, which basically gives you all of the data for one particular height. Second type, so we also have this one in our integration. Basically, it provides all of the data that we aggregated for one particular height. And second type of handler is the event handler, which I have right here, and it basically gives a subgraph developer an ability to trigger a function on every event, and this is like the Tendermint event. So one example of an event is like rewards, and this is what we actually are getting here. So if we go to the SRC mapping, we can see like the source code of this handler method, and yes. So here it's very simple code. Like the example is only here to demonstrate the usage of the handler. So it's not really complex, pretty easy, but it just demonstrates what it's supposed to show. So how to use like an event handler. So as you see, like the data we get is this event data. I can open it up real quick. So we have right here, this is kind of part of the data model, right? So what we receive here is a event structure and header only block, which basically is like a header of a block. This is like for context mostly, but the most important thing is this event where we basically get like all of the attributes of an event, and like a pretty nice DSL that we added for basically obtaining the values of a particular event attribute. So we actually use it here. So from the rewards event, we extract the amount and the validator address, store it into variables, and then create a reward entity and store it in the Subgraph database. So it's I think it's pretty simple. So yeah, this is like an example subgraph, and now we can just build it and deploy it to my local graph node instance. So the commands here are pretty much the same as with Ethereum. So it's basically ARM build, which basically builds the subgraph. I think I already have some code gen command run. So basically, I think we need to start with code gen actually. If it's like the first time you actually building the subgraph, then it's yarn build. And the next step is to actually, like, first of all, create the subgraph in my local graph node instance, and then just deploy it locally. So as you see, it's successfully deployed to my local instance and it started indexing the subgraph. So the process is basically exactly the same as with Ethereum, with that difference that like this sort of different protocol specified in the manifest file. So if you open a link here, we can actually query the subgraph. So this is the README file of our example. So there's actually a query that we can use to basically fetch all the validators that we have, that the subgraph indexed so far. And yeah, here's like the variable that is provided. And yeah, if we run it, we see that we just get the data that the subgraph indexed so far. So yeah, this is like a brief presentation of how it works. As you see, it's very similar to the usual flow. So yeah, so maybe you have some questions.
I see that Derek typed a question in the chat, but I'm not sure if I understood what he's talking about. So maybe you can explain a bit better what you meant by that it doesn't have the params listed event.
Let me see the question. Okay, all right. So yeah, so in this case, it's actually kind of in this way it's different from Ethereum. So it's not relying on the ABI as it would be in the Ethereum integration, but that's one of the reason is because we actually integrated this on a Tendermint level. So once we get the data, we don't really have all of those chain specific information. We only have events, which is like the generic structure for storing all of the data, right? Which is actually implemented on the standard level. So in this case, we don't have something like an event signature. All of we receive, it comes in the form of event attributes. So for instance, we have an event, which is the reward, like in the example I showed, but all of those, let's say, parameters to the event are actually event attributes. So let me share the screen once more. So yeah, so that would be like the event parameters that you would have in Ethereum that would come in the form of attributes here. So as you see, there's the amount attribute and the validator attributes. They are both strings because all of event attributes in Tendermint come in a form of string. So that way, it's just like a different way of obtaining the same data. So, and what you actually, yeah. So this is like it's kind of different, but you can then get the same data inside the subgraph.
Hey, Bartosz, I'm happy to take the next question.
All right.
Okay. Hi, Vincent. So, yeah, as we've said before, if you've never seen Cosmos, you need to think of, so on an Ethereum-based chain, you've got smart contracts, right? Hey, you want to develop a dApp, you want to do some work, so you build a smart contract that runs on the chain. If you need to upgrade the contract, you don't shut down the entire Ethereum chain. You just kill your contract and update it, or repurpose it, change the starting address or whatever. So what you need to think about, if you've never looked at Cosmos, I don't know if I am I allowed to share my screen, Pedro?
You should be able to, yep.
Okay. So let me pull up a site. It's easier to explain if I just pull this up. Let me attempt to share my screen, everyone. All right, let's see here. There we go. Okay, can folks see my screen? Yes or no?
Yes, I can see it.
Great, awesome. Thank you. Okay, everyone, if you're not familiar with Cosmos, this is a really cool site. This is called, just Google Map of Zones. And what I'm showing you here is actually all the Cosmos chains. Okay, you see Juno, CosmosHub, that's like the hub of communication amongst the chains. Here's Osmosis. Osmosis is kind of like, it basically is Uniswap for the Cosmos ecosystem. So this is the Cosmos world. Each of these chains are L1 chains, but in Cosmos, you really the model is you don't write. Okay, let me take that back. In Juno, you can actually build smart contracts with CosmWasm. You can write CosmWasm contracts that are kind of general purpose, but a majority of the other chains, the apps do one thing. Okay, these are really app chains. That's how you have to think of this. These aren't smart contracts running on one chain. These are really their own app chains. For example, if there was a bug, I think recently there was a bug in Osmosis, or if there's a bug in the chain, it's actually in the app layer. So they literally have to stop the chain, fix the bug, and then restart the chain. So this is a different mindset when you're thinking, looking at more EVM-based chains, contract, dApp developers versus the Cosmos ecosystem. So CosmosHub does one thing. All these chains really do one thing. Does that help explain a little more of, Vincent, back to your question? Okay, I hope so, maybe. Okay, so we got some more questions here. Maybe you want to take that one, Bartosz, how does it deal with tuples, arrays?
Sure, yeah. So let's say that I haven't said that before, but it's actually important. So we have this event system that only allows, and this is defined on the Tendermint level, right? So it's pretty simple. It doesn't handle tuples or arrays. All it does is basically an array of like a associated map of strings. So this is the way that events are related in the Cosmos ecosystem. So that is what we get from like the extracted data from each chain, and this is what we pass to the graph node. So it's what it is. It's basically an array, like a list of strings with like a hash, let's say, of where a key and the value is a string. So that's the way we can obtain event data. But there's actually more than that. So apart from having this event system, which is basically string to string hash, there are also messages, which are really, this is where the data, like the really detailed data is. So apart from the event handler that we have, we also have like a transaction handler. This is a completely new handler that we added to the graph for the Cosmos integration, which actually allows you to obtain all of the data that is passed in the Cosmos, those Cosmos chains. But for that, you actually need like all of the message definitions. So each transaction in Cosmos contains messages, and messages are specific to a chain. So CosmosHub messages are different than, like, Osmosis has its own set of messages, like Juno has its own set of messages, and each chain, let's say, defines its own messages. So by using transaction handler, and in the near future, the message handler, which actually triggers on each message. So each transaction contains multiple messages. That's a brief description of it. So by using either of those two handlers, you can actually obtain much more data that we would get just by relying on the event handler. There's a question: are messages and events the same thing? No. So yeah. So messages give you like all the detailed data, but for that you need those message specific, like those chain specific product of messages. This is that's because we actually integrated it on a Tendermint level, right? we don't know which messages are actually relayed along those different networks. So to decode them in a subgraph, you actually need to have those protobuf messages for that specific chain. And having that, you can actually decode all the data that is basically all the information that circulates around in the network. But with an event system, you can actually get a lot. I would say, I think 90% of the data that also comes in messages in transaction, they are also relayed in the form of events. Just using this simple framework where you just get a bunch of strings. So we can in our integration you can actually use both. So if a simple strings are enough for your use case, then you can use the event handler. If you need more data, like more detailed information, because not everything can be passed as strings. There are some different data types that you might want to just to have instead of just relying on strings. Then you use the message handler or transaction handler, and then you can have access to all of the data in the original format, let's say.
Going back, based on that, I think it was pretty clear, but based on that and going back to Vincent's first question on, what would be the process for us that are mostly, used to build EVM-based subgraphs? How would you then go to, let's say, a protocol or a chain and figure out what are the messages, what are the data models, the structures, how can I build a subgraph for it, so to index all of these things that are happening there? What would be the best way to, hope that's clear.
Sure. Yeah.
I was going to say I checked on the question and I have it right. So if you want, Bartosz, I can take on that.
Yeah, sure. Go ahead.
All right. So let me just share my screen real quick. This one. Can you see it?
Yep. It's coming up. Yep, it's there. Yep.
All right. So this is again a very simple example. Let's say that I want to build a subgraph on Osmosis, right? But I'm not sure what's the data model on the chain or what are the messages in the chain. As Bartosz said before, remember that messages are make it bigger. Sorry, I hope that's better. So remember that messages are defined on each chain and on each module of the chain. So for example, if we go to the Osmosis repository and I want to know which messages are defined for this chain, I could go to the proto directory, because normally those are always in the proto directory. This is where the protobuf definitions are, that's what the messages are, protobufs, right? And then you will go to Osmosis, and then here you would see all the different modules that the Osmosis chain defines, right? We have a module for the JMM swap, right? The automated micromaker. We have another one for the superfluid module to allow superfluid staking. Again, as Jared said, remember that all of this are written into the chain. It's not like in Ethereum where you have smart contracts that allow you to stake or do whatever. Here, all the code is in the chain, right? So, for example, I would pick up the GAMM module, and I would go to the TX proto file, which is normally the file that contains the different messages. And here you will see all the messages that are defined for this. Well, these are the messages, but these are the RPC calls, which is the same for this module, right? And normally these messages represent the action that can be taken within that chain, because a message in the end is just it's what really triggers the state change, what really triggers an action in a Cosmos, Tendermint-based chain, right? So, for example, the first one is the join pool, message join pool, and if I go a bit down, I can see the different parameters the attributes that this message has. So it has a sender, the pool ID, which would be the pool where I want to do the swap, right? And then the amounts that go into the swap, right? Then I would take this and I would go to my subgraph, and I would probably generate a schema object, right, with this different attributes, so I can map them in the mapping function as Bartosz was showing before, right? Like I have an example here open. I don't think it's the same because this is with events, right? This is the by the way, this is the official.
Can you zoom in a little bit?
Yeah,
again,
sorry.
Yeah, thanks.
I'm sorry.
It's fine.
Wait a second. Sometimes my wheel just stops working, and I do it like this. Okay. Okay. Is it okay now?
Yeah.
I hope it's better.
Thank you.
Yeah. So here instead of we're handling with events, which are another part of the Cosmos kind of like Tendermint-based change, but they work the same way, right? They have some parameters, right? So as you can see here, I'm mapping into my token swap like object that I defined in my schema, right? I'm mapping the data that comes from the event, which would be similar to this data, the sender, the pool ID, and the shares. I'm mapping them to an object that I've created in my schema, so I'm able to save it, right? And that's the process that we would normally follow to be able to store information on the Cosmos chain, right? For the transactions, it would work. Let me see if I can here. Yeah, I think this is gonna be much better. Let me zoom in again. Yeah, so here I have the transaction data. Remember, in Tendermint-based chains, a transaction is a wrapper of messages, right? That we've said that messages are what actually triggers the state change. So a transaction contains a set of messages, right? And what we do here is like we get this transaction data because we are using a transaction handler, as Bartosz said before, and then we are looping through all the messages that transaction contain. And if we happen to spot one of the messages that we're interested in this case, this is a delegate message. It could be the join pool message that we were talking about in Osmosis, whatever message is for whatever chain, then I save that delegation. Again, I map the attributes from the message to my object, find in the schema, and then I save it into the database. And this is how you go from spotting what you're interested in, seeing what the data looks like, and then mapping it into your object and ultimately saving it into the database. So yeah, I think that's a super high level the process that we normally follow. So yeah.
Yeah, I think that was super helpful seeing the whole thing end to end. I think. Oh, Vincent, you were going to say something. Was that you?
Yeah, I'm reading the chat.
I thought I was hearing Vincent trying to talk. But yeah, he posted a good question. Is it appropriate to think of messages as call traces in EVM chains? Sounds about right. Sounds like the right mental model, I guess.
Yeah. I think it's I think it's a good analogy. Yeah, so these are like completely two different right? Ecosystems like EVM chains and Cosmos chains. So there's not always you can find like a good comparison between them, like the concepts in this ecosystem and that one are kind of different, but yeah, in terms of like this question, I think it's a good way to think about messages as call traces because they are basically serve the same purpose, I think. So if you track all of the messages, you're actually getting to know what is happening on the chain. So yes, there was a question about like an array of events, I think. So let me share my screen. So here's the Cosmos SDK repository. And these are like the docs for the events, something that I want to show. So here's basically how events look like. So you see it's like a key value hash where both key and value is a string. So actually, like when you have an event, each event can contain multiple those attributes. An attribute is like a key and value which are both strings. is actually like an array of event attributes where you have like this string to string key value mapping. So this is how it looks. So this is, for instance, you have the message sent, which is basically like a transfer of tokens defined by the bank module in Cosmos SDK. The Cosmos SDK is what, like, I think all of the chains in the Cosmos ecosystem are built upon. So all of them actually use those modules. So for instance, to transfer tokens, this is like the message that is actually used. And these are like the events that are actually relate along with the message. So here we can see like all the attributes that this this event has. But if we look to the protobuf definitions, you can see like what the message looks like. So this is like the protobuf messages, protobuf message or protobuf definition for this message sent. So this is like the two different things, but as you see, they contain pretty much the same data. Like in this case, it's exactly the same data because you have from address and to address, and they are both strings. So there's nothing more you can actually obtain from like decoding the message that you wouldn't get from just looking at events. But that's not always the case. Sometimes there are like different data types that are used inside messages, but events for that message are always related as strings. So you can think of it like as two different methods of obtaining pretty much the same data, and it depends on your use case, like which one should you use.
Just being conscious of time. We are a little bit over time. I'm not sure if you have final questions, but just to let you guys know, maybe, I don't know if Bartosz, Jared, if you guys can, maybe we can end at 45.
Sorry, Pedro, you cut out there in the middle there. Or what were you asking? If we could go a little longer?
Correct.
Yeah, I mean, I can. You want to go 7 more minutes? Is that what you're asking?
Yeah, just being conscious of time, really. I can stay, obviously, just making sure that you guys can also continue answering questions folks might have.
Okay.
I see there's still some activity in the chat.
Sure. So I'm happy to stay a little longer, but with respect to Bartosz, Mark, and Mark, I'm not sure.
Yeah, no problem.
Thanks, sir.
I can also say.
I see Vincent is writing. Vincent, if you want to use voice chat, if you can, maybe might be quicker.
Oh yeah, I just finished typing. Basically, I was asking like, what are some dev tools that you could share that could be helpful for subgraph developers when they're building or debugging subgraphs?
Vincent, I'm not clear of any of those tools in the community. Anyone on the call, do you have any more insight there?
Yeah, so exactly. So there's MintScan, there's CosmosScan, but these are basically the block explorers for Cosmos, if that's what you meant.
Yeah, Vincent, are you looking for something more than block explorers?
Yeah, there's like in the Ethereum ecosystem, there's a lot of just like community built tools that do a range of like different stuff that could help debug the subgraphs. I'm not sure what's the right way to describe them. Just like usually they allow you to do stuff that's not supported by the block explorers. So you can go either deeper or you can just for example, Tendermint and ETH it basically prints you the stack trace of a call, which can help you debug like deeper into a particular event.
Awesome. So Mark Preston, I know you're somewhat involved in the Cosmos Discord channels. Have you ever seen anything like that as Vincent's describing?
I haven't, and that's something that we kind of touched on a little bit before, is that there isn't really a lot of big indexing or development-based tools in the Cosmos ecosystem. That's one of the big things that this integration actually brings. So what we've been doing more often than not, it's a little difficult, is literally just stopping the chain and investigating the blocks as they happen. You don't really get a stack trace to go back further. It's unfortunately a little bit sparse, I guess, which is unfortunate. But maybe that's something we can work on from this and try and develop something upon that.
Yeah, Mark, that's a great point. For everyone on the call, I think the real amazing thing here is there's not, from what we've seen, not much tooling, and if we can get our Tendermint-based changes into upstream into Tendermint, this tooling would be amazing for anyone building on Cosmos or Tendermint-based could have this, index tooling built in, which would be a big win for the community.
Mac also raised a good question. Don't know if you folks want to address. How would you go about running this thing locally, just for development purposes?
I can talk about this. So there's 2 or 3 ways that you can do this as such. Obviously, right now, there's a benefit at the moment where it's on hosted services, which is great. The other side of it is there's links there where we have created with Firehose and Streamfast to instrument your own chain from the Genesis block. Start streaming blocks into Firehose, which acts like a block storage almost. And then you attach your local graph node and IPFS on your local development and just point it at that endpoint. It's as easy as pointing it to, I guess, localhost 9020. And it'll just literally start just showing the blocks for you. It is there in those documentations themselves, and a lot of it is Dockerized as well. So you can literally just spin up the Docker containers and then create your graph node as you wish. Once it's pointing to the correct endpoints inside Firehose, and that will do the rest of it. It is fairly straightforward. I think there's actually another person in the community in the Cosmos channel here actually did a really good guide on how they did it with a chain that we haven't worked with yet. They did it for their own chain. I can find that link and send it on. And they did a really good write-up of how to do the... I'll check it out now, Mac. But they actually did a good guide that covers GraphNode and everything the whole way through. I will find that link and I'll send it on now.
Amazing. Thanks so much, Mark. All right, I think we can wrap it up here. It's 45. Any final questions? Going 1, going 2. Boom, that's it. Okay. Thank you all. Thank you, Jared. Thank you, Mark. Thank you, Bartosz. Hope I'm not forgetting anyone.
Yeah, well, both Marks. And thank you, Pedro, for facilitating and making this happen.
My pleasure. Thank you all for joining. This is also being recorded, I believe. Payne will be sharing, or we will be sharing a link once we upload it to YouTube, so you folks can watch it later if you want to. Again, thank you all. See ya.
Take care. Thank you.
Thank you.
Thank you.